In this video, let us look at a system that has two linear equations, and the system is y equals 3x plus 8, and then 2y minus 6x is 16. So far we have two methods for solving this system by hand, and the two methods are substitution and elimination. Let us use both and see that we get the same result. And because we get the same result, the user, whoever is solving the question, gets to choose whichever method that the person wants to use. And so to illustrate what would happen if you choose substitution versus elimination, we'll do both of them in the same example, and we'll come to the same conclusion. So here goes. Substitution first. Substitution means that we will solve one of our equations for either x or y and use that information in the second equation. Now the first equation already happens to be solved for the y, so if this is y always, then this is always going to be y. So let us substitute as the name suggests. So 2 times, and the y becomes the 3x plus 8. The rest of the question is unchanged. So minus 6x is 16. Now we follow the order of operations to simplify and solve. So multiplication is first, there was nothing to be done inside the parentheses. Order of operations is PEMDAS. So parentheses, exponents, multiplication, division, addition, subtraction, and we're simplifying in descending order. So 2 times 3x makes 6x, 2 times 8 makes 16, and then the rest of the question as it was, minus 6x, 16. Now we notice that a lot of things cancel, namely 6x minus 6x, and that leaves me with 16 is 16, which is always true. Now, always true. Now, the fact that it is always true means there will be infinitely many solutions. That also means that we will have to write the final answer as a general solution. So we need general solution. That also means that we have two lines that are really the same line. So we have the same line twice, and that is why we have infinitely many solutions, because every single point that is on the first line is also on the second line, because it's the same line. And let's rewrite that equation and have a look at it a little bit closer. So here is y is 3x plus 8, 2y minus 6x is 16. So this is our solution using elimination method. So this is, using substitution method. So that's finished. Now let us use the elimination method, and for that we will need to manipulate this equation, this system a little bit. So for elimination, we will add, right? Elimination is also known as addition. So we will add the terms and the two equations together, and we add it in such a way that one of the variables, one of the letters, has to cancel off. So to do this, when we use elimination, we always write the equation in such a way that all the letters are on one side, so letters, and usually on the left, and the numbers, the last number, the constant, is on the right. And since we are going to add, we align like terms under each other. So the x's under the x's, the y's under the y's. So for the first equation, that means the 3x has to go on the left. And to cancel 3x, we need to minus it from both sides. And that makes negative 3x plus y is 8. Now the second equation is already all the letters on the left side, but the position is opposite from what we have on the top. So let's switch the position for the second, making it negative 6x plus 2y is 16. Now at that point we notice something strange about this equation, because the second appears to be double of the first, right? If we simply multiply each number by 2, negative 3 will turn to negative 6, 1 will be 2, 8 will be 16. So I really don't have any extra information here in the second equation, it's only the first one doubled. Now, using elimination, let's add these equations in such a way that one of the letters cancels. So let's cancel x. To do this, we'll multiply the first equation by negative 2, because negative 2 times negative 3 will make 6, and 6 with negative 6 will cancel off. So multiplying through all the way every single term, we get positive 6x. Negative 2 times y makes negative 2y, and also remember the other side, negative 2 times 8 is negative 16. Now the second equation is unchanged, which is negative 6x plus 2y is 16. Now we are ready for elimination. We add the two equations and we find that x's cancel off, y's cancel off, that leaves nothing. And then on the other side, 16 minus 16 also cancels off and leaves 0, which means 0 equals 0, and that of course is always true, and so always true. And so we come to the same conclusion, that we have the same line twice, and we need to write the answer in the general form. Now, we haven't done it in the first equation because the solution would be exactly the same for both. So let us write this answer in general form. So general form involves listing all of the solutions to our system. So if we would pretend to write every single point that is on both of these lines, which is really the same line, how could we do it? Well, the point naturally has two coordinates, x and y. So if somebody gives me x, where do I get the y? Well, the first equation says that the y is always going to be 3x plus 8. So instead of the y number, I simply rewrite 3x plus 8. Now, some computer systems would not like to use the same letter that we've used in the original question, and so alternatively, we can replace x with anything else, a, b, c, whatever other letter except x and y, which we already had. So alternatively, we could say it's a, and then 3a plus 8. Now, a could be anything, any number we want. And so if we, for instance, if we plug in a as 0, that means this a becomes 0, and then 3 times 0 is 0 plus 8. So that means 0, 8 would be a solution to our system. But we could also try a as 1. And if we do that, we get 1, and then 3 times 1 is 3, plus 8, which is 11. And that's also a solution. Obviously, we can choose infinitely many numbers for the a, and that would be infinitely many solutions. So we can't possibly write infinitely many numbers like this and have all the solutions listed. We could if there was just one solution. We could if there is no solution, because we can simply say no solution. But when there is infinitely many, the only way to do it is to write the answer in general form, like so. So this is the final answer to the system of linear equations that has infinitely many solutions. Now we could make a sketch out of this and see that the two lines are the same, but we already see it in this form here, because we see that all the numbers are exactly the same, just doubled. So if we were to graph it, we'll see the same line twice. One line will trace over the second line, and we will see nothing else. So it'll look just like one straight line. And that's all for this video. Thanks a lot. Take care.